Okay. So what is least common factor? That means, for an example, if you have to
12.
if you have to ring
Yes.
a school bell after every 4 hours, okay, after every 4 hours, and one bell is ringing after every 6 hours, and one bell is ringing after 12 hours. So that means, what is the time when you hear all 3 bells together? What is the first time when all the 3 bells will ring together? Okay,
12.
yes. So how do you do that? This is my 4, okay? This is my, sorry. This is my 4, and this is my 6, and this is my 12, right? So 6 and this will be almost like 12. So you have to take another, how many 4s will come? How many 4s will come?
3.
3?
Yeah. 4 3s are 12.
How many 6 will come?
2.
Okay. So one bell you will hear, after here you will hear one bell, then one bell you will hear,
Yes.
and then one bell you will hear, and then this bell, here you will hear all the 3 bells ringing together.
Yeah.
So that is the LCM. That is the LCM. Now what is the HCF of this 4, 6 and 12?
2.
That means,
2.
yes. Now what does it mean? What does it mean when we talk about HCF? So I have 4. Okay, this is my 4. And this is my 6. And this is my 12. So when I say highest common factor is 2, means what? Means when I equally divide, this is the first place where I can equally divide. Right? When I equally divide, then the second will come here. You know? And then it will come here. And then it will come here. And then it will come here. So 2 is the number which I can take to get the equal factors. All these factors are now equal, right?
Yeah.
So what is that number which is the highest? Means I cannot take any number after this to have the equal divisions, right?
Yes.
So this way you have to make the children understand that what is the meaning of highest common factor and what is the meaning of lowest common multiple. Now you can understand why lowest common multiple was 12 there. Now you all can understand why it was 12.
Yeah.
Because that was the first time when all the 3 bells were ringing together, right?
Yeah.
And here it is the highest common factor because 2 is the highest common factor which can equally divide all these numbers. Right? Any doubts?
No, ma'am.
Okay.
No, ma'am.
So this is called pictorial approach where you are showing through picture and then you take to the abstract form where you tell them the method, the normal method which we do to get the LCM, you know. This way we are taking HCF for all the numbers, right? the way you all have done yesterday. So that is an abstract form. Okay, जहां पे आप क्या कर रहे हो वो एक एब्स्ट्रैक्ट फॉर्म है, लेकिन उसकी बेसिक अंडरस्टैंडिंग तो ये है ना, ये तो होनी चाहिए. तो इसको हम बोल रहे हैं पिक्टोरियल. और ये जो हम नॉर्मल जो कैलकुलेशंस करते हैं ये एब्स्ट्रैक्ट फॉर्म. और पिक्टोरियल से पहले भी कंक्रीट आना चाहिए. एंड कंक्रीट मतलब क्या, जो अभी आपने वीडियो देखी थी उसमें जो ब्लॉक्स थे, तो आप कुछ भी चीज इस पिक्चर फॉर्म में कराने से पहले you have to use some objects, है ना. जैसे यहाँ पर what object can take, can you think of any object you can take? इसी चीज को आपको ऑब्जेक्ट के थ्रू अगर कराना है, कोई चीज दे के कराना है, what will come to your mind? What you can
पेंसिल.
चलिए आप लोग, मैं आपको टाइम दे रही हूँ, आपको सबको एक 5 मिनट्स में कोई भी अपने घर की कोई चीज यूज करके मुझे बताना है. एक एग्जाम्पल मैं आपको दे रही हूँ कि आप बिंदी का पैकेट यूज कर सकते हो. ठीक है, 5 मिनट्स आई एम गिविंग यू.
in your math classroom. So first of all, how to make these very inexpensively. You could buy one or buy a set at a teacher supply store or online, but I made this one very inexpensively with some elastic craft rope and pony beads that I ordered online. So that's definitely an option. You make 10 groups of 10 so that it's 100 bead string altogether. Now I want to talk to you about how we can use the bead string before we transition to the open number line. So we know the importance of number lines and open number lines, and we know the power of them in the classroom. However, that's sometimes where we start when we're explaining concepts. And when we start with an open number line or a number line, we've actually skipped a step because this is a representation of what we want our students to do. However, we need to start in the concrete phase. And the concrete phase is when our students can actually handle materials and work with them and explore and investigate with them. So here's what we might expect our students to understand when we explain using a model like this. We might expect them to know that we could add 1 more to make 10, and then we could add 3 more to make 13. So we're just expecting them to understand that concept of taking 1 from the 4, giving it to the 9 to make 10, and then using those 3 leftovers to make 13. However, that's a really hard thing to comprehend, and it's a hard thing to see in your head when you have nothing to connect it to. Now, if you are not working with low numbers in your classroom, obviously you could substitute these for higher numbers. Now let's take a look at what a difference it might make when we use a beaded number line. So here we can ask our students to show 9 plus 4 on the beaded number line. Now here we have 9 on one side, 4 on the other. Now what do you see here? Well, it's really apparent that to add 9 plus 4, we would start with 9, add that 1 more to make 10, and then we have just those 3 whites left over to make 13. So this is the precursor to this because it helps give our students a visual. And it helps give them something to connect to, something to build those connections in their mind before we get to this point. Now, obviously, addition, subtraction, this is amazing, but you can even use it for multiplication. Or division for that matter. So I just want to show you a really quick way that we might use a beaded number line for multiplication. So let's say we begin with, I'm going to begin with the number line actually. If we want our students to show 4 times 5 on the beaded number line, they can easily show that like this. So we've used some clothespins to mark off those numbers, and we can easily see 5, 10, 15, 20 on the beaded number line. Now what else do we see here? We can see that 4 groups of 5 is the same as 2 groups of 10. We could see that 3 groups of 5 plus 1 group of 5 makes 4 groups of 5. We could see that 4 groups of 5 subtract 1 group of 5 makes 3 groups of 5. There is so much learning on this beaded number line. Now, since we've built this in a concrete way, now we can represent it on maybe with some skip counting. Maybe we might do something like this. And now where we see that 4 jumps of 5 makes 20. So after we've worked considerably with concrete materials and then with representational drawings or representations, then we move into the abstract. So don't rush this process. Sometimes when we learn new operations, and especially in older grades where we kind of feel sometimes like we're past manipulatives, your students are not past using manipulatives, sorry, I'm having trouble with that word today, to build relationships. Taking the time to work with.
Okay, so I hope you understood that first we have to show the concrete, with the help of the beads. What is it? Then it will go in their picture, in their mind as a picture, and then it goes in the concrete, in the abstract form. So when you are showing it on the beads, that is concrete. When you are doing this linear equation, that is the pictorial. And then you do this 4 into 5, which is abstract. So this is abstract, but generally what we are doing, we are only teaching this thing, and they really
Abstract.
they do not know what is actually happening. They are only just rote learning this thing without understanding this concept, and we think that that child is very good at math, but is he really good at math? Does he really know this thing? So if he can relate this abstract to this picture and this, if he can relate all three of them, then we can say that the child is good at math, or he has the concept, he knows the concept behind. Otherwise, what he is doing, he also doesn't know. He's only being told to learn this, and so he's just learning this. So while you are teaching math, make sure that the child knows what he is doing and why he is doing that. Am I right?
Yes, ma'am. Yes, ma'am.
Okay, so as
Yes.
a math teacher, your responsibility is not that the child should get 10 on 10, but also that what problem he is solving, he should actually relate it with the real life applications.
Yes.
Okay.
Yes, ma'am.
Okay. So that is all for today. Any doubts?
Ma'am,
Ma'am,
will you share the links, no?
I have shared that. Okay, I'll share.
Okay, ma'am. Thank you.
Please do.
Ma'am, one example is there which is generally used for this LCM, HCM is of the what is called it as traffic lights. Yeah, there is this concept. It's means that is an example of this LCM, HCM. But I can't explain it कि वो कैसे होता है. मतलब ये होता है कि जनरली कि वहाँ के एरिया में वो लाइट सेट किया जाता है जो
सेम
प्रोग्रामर रहता
सेम
है
ही है
वो.
ना, बेल रिंग कि
हाँ,
तीनों बेल एक साथ में कब रिंग हो रही है. सो इट इज.
लेकिन तीनों बेल्स मीन्स एट ऑफ डिफरेंट प्लेस द ट्रैफिक लाइट्स नो.
यस यस.
ओके.
ओके.
एक साथ वहां का रेड ऑन होगा,
ऑन
एक साथ
होगा.
वहां का येलो
हाँ
ऑन होगा और एक साथ वहां का ग्रीन. ओके.
हाँ.
सो दे कांट मिक्स्ड एक साथ ही एक जगह पर वो नहीं आ जाएंगी ऐसे. करेक्ट ना. ओके.
ओके. सो जो भी मैंने आज लिंक्स आपको दिए, प्लीज आप एक एक करके उन पे क्लिक करेंगे, सो दैट ये बेसिक छोटी छोटी चीजों से आप मैथ के कॉन्सेप्ट्स बच्चों में बहुत अच्छे से इम्बाइब कर सकते हो. ओके.
यस 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 यस.
ओके.